morning to all. I am Dr. P. Subramanian, Department of Civil Engineering. Today I am going to share the topic of engineering geology. Why you are going to study for the engineering geology? The engineering geology is related to the civil engineering. First of all, what is physical geology? You know the all civil engineering. The geology in civil engineering. Physical geology, lot of division is the first branches of geology, structure of earth and its composition, weathering of the rocks, scale of weathering, soil types, landform and the process associated with the river, wind, groundwater and the sea, relevance to the engineering, plate tectonics, everything we are going to the study for civil engineer. So civil engineer, this part only study or going to the building construction is better, or otherwise the building construction is not better. The physical, first of all, you know the physical geology. Introduction, physical geology introduction, effect of natural agencies like the wind, running water, subsurface water, lakes, ocean, glaciers, organism, volcanoes, earthquake, taking part of the changing in the surface of the earthquake belts in India, everything we are going to study for physical geology. So, meaning of geology. What is the geology? The geology in great words, the geo means earth. We are going to the study for earth. Fully study for earth. And logic means science. We are going to the study, logically, study totally, we are studying for the earth. It is a branches of science dealing with the study of earth. It is also known as the earth science. The study of earth comprises of the whole earth. It is origin, structure, composition and history, including the development of life and the nature of process. That's called the meaning of geology. Why study of earth? We are part of it, test to test. The humans have the capability to make the rapid changes. All construction from houses to road to dams are affected by the earth and thus they require some geologic knowledge. All life depends on the earth for food and nourishment. The earth is there every day of our life. The geology, what is it? Geology is the study of earth. It includes not only the surface process which have shaped of the earth's surface, but the study of the ocean floors and the interior of the earth. It is not only the study of earth as we see today. Where do geological engineers work? Geological engineers work for the federal or state agencies or for the construction, petroleum department or mining companies. Many geological engineers today are hired by the environmental firms or the renewable energy companies. Jobs are available in all parts of the US. What is the difference between the geology and the geological engineering? A geologist studies the earth, the material of which it is made, the structure of those materials and the process acting upon them. A geological engineer takes this knowledge and applies the principle of engineering, dynamics, mechanical properties, etc. to assess the risk associated by the site the condition, design structures and foundation, conduct the site reviews and development the solution to problem in the environment. Both are existing carriers that are similar but still quite the difference. So definition of the geology. The science deals with the study of Earth as a planet. It includes the essence of scientific studies dealing with the origin of the Earth and the age of the Earth and structure of the Earth. It is also deal with the evaluation, modification and the extension of various surface and subsurface physical features like mountains, plains, valleys, basins, caves, etc. So, objectives of the engineering geology. The objectives of the engineering geology can be understood. First one, they enable as a civil engineer to understand the engineering implication of certain conditions related to the area of construction, which are essentially the geological in nature. Second one, it enables a geologist to understand the nature of geological information, that it is absolutely essential for a safe design and the construction of the civil engineering project. Third one, the principal objective of engineering geologists, thus the protection of the life and the property against the damage caused by the various geological conditions. These are the objectives of the engineering geology. The scope of engineering geology. The scope of engineering geology is best studied with the reference of major activities profession of the civil engineer, which are construction, first one. Second one, the water resource development. Third one, the town and the regional planning. These all are field, the scope, very large scope is available for the studying for engineering geology. The importance of the geology from civil engineering point of view. Before constructing road, bridges, tunnels, tanks, reservoir and buildings, the selection of the sites is important from the point of stability of foundation. Geology provides a systematic knowledge of construction material and their properties. The knowledge about the nature of rocks in tunneling and the construction of the road. The foundation problem of dams, bridges and building are directly related to the geology of the area where they are built. 2. The knowledge of the groundwater is necessary. The construction with the excavation work, water supply, irrigation and many other purposes. The knowledge of erosion, transportation and deposition by surface water helps in soil conservation, river control. Geological map and the selection of help considerably in planning many engineering projects. If the geological features like fault, joint, bed, fold are found, they have to be suitability treated, hence the stability of the rock structure is the important. So different branches of the geology. First one, physical geology. Next, crystallography, mineralogy. You are going to study only for minerals. Petrology, you are studying for rock. You are studying a lot of rock types, igneous. For example, 3 types of the rock. Petrology, 3 types of the rock is the igneous and metamorphic and sedimentary rock. Then the structure of the geology, structural geology. What are the structure is available? First one, the fold, fault, joint, the lot of structure is there. Then the stratigraphy, paleontology, historical geology. Historical geology means ancient. For example, the Jurassic, dinosaur, everything we are going to the study for the historical. The economic geology. Economic geology means the valuable minerals ore. Mining geology, the lot of mines, for example, the gold mines and copper mines and the limestone mines, the lot of mining is there. The civil engineering geology and the hydrogeology, we are going to the study for water. We are going to study for water for hydrogeology. The Indian geology, resource engineering, photogeology. There are a lot of different branches there. First one, the physical geology. Branches of geology. It deals with the various process physical agents such as the wind, water, glaciers and the sea, waves, run of the agent, the modification of the surface of the continues. The physical geology includes the study of erosion, transpiration and deposition. The study of physical geology plays the vital role in civil engineering those. It reveals constructive and destructive process of the physical agent at a particular site. It helps in selecting a suitable site for different types of the project to be undertaken after studying the effect of physical agent which go on modifying the surface of the earth physically, chemically and mechanically. Crystallography. Crystallography means the branches of geology. It deals with the study of crystal. A crystal is a regular polyhedral bounded by the smooth surface. The study of crystallography is not much important to civil engineering, but to recognize the minerals, the study of crystallography is necessary. Third one, mineralogy. As a branches of geology, it deals with the study of minerals. A mineral may be defined as a naturally occurring homogeneous solid, inorganically formed, having a definite the chemical composition and order the atomic arrangement. So the study of mineralogy is most important for a civil engineering student to identify the rocks. In industries such as the cement, oil and steel and fertilizer, glass industry and so on, a lot of is there in the production of atomic energy. So petrology, these also branches of geology, it deals with the study of rock. A rock is defined by the aggregation of minerals found in the earth's crust. The study of petrology is most important for the civil engineer in the selection of the suitable rock for building stones, road, metals, etc. So this one is the very important for the civil engineering student. The structural geology. As a branch of geology, it deals with the study of structure found in the rock. It is also known as the tectonic geology or the simply the tectonics. The structural geology is on the arrangement of the rocks and plays an important role in civil engineering in the selection of suitable sites for all types of the project such as the dams, tunnels, multi-story building, etc. Stratigraphy and paleontology. Stratigraphy means these one branches of geology. It deals with the study of stratified rocks and the correlation. Stratified rocks, that is the stratigraphy. Paleontology, this also the branches of geology. It deals with the study of fossils. So, and the ancient remains of the plants and animals are referred to as possible, are useful in the study of evolution and migration of animals and plants through the ages, ancient geography and the climate of the area, everything going to the study for the paleontology. Paleontology, that means the ancient to plants and animals. Next one, historical geology and economical geology. Historical geological means the study of both stratigraphy and paleontology. That means the history of the geology. For example, the foot fossil, then the gold field, then the lignite, everything the historical geology. It is used as civil engineering to know about the land and the seas, the climate and the life of early times upon the earth. The previously how the earth is formed, what is the age of the earth, everything we are going to the study for the historical. The economical geology, this one is the main thing. It deals with the study of minerals. So, the valuable ore minerals is there, the rocks and the materials of the economic importance like the coal and petroleum. This one is the very important. The economic geology, coal, petroleum and diamond and everything, the lot of is there. The silver, platinum and copper for example of the economic ore minerals. Then mining geology and the civil engineering geology. Mining geology deals with the study of application of the geology of mining engineering. So, mining engineering in such way that the selection of suitable sites for quarrying and mines can be determined. We are going to the suitable. First of all, we are going to the suitable, which place is suitable for the mining work. That place we are going to the geological student find out. The civil engineering geology, as a branches of geology, it deals with all the geological problem that rises in the field of civil engineering along with the suitable treatment. Thus, it includes the construction of dam, tunnel, mountain, road, building, stones, etc. So, these all are we are going to the study for civil engineer. So, hydrogeology or Indian. Next one, Indian geology. What is the meaning of hydrogeology? Hydrogeology, the study of both quality and quantity of water that are present in the rock in different state condition. Moreover, it includes the atmospheric water, surface water and underground water. Atmospheric surface water means, for example, lakes, river, these are all surface water. Underground water means borehole water. We are going to study for the underground. Then atmospheric water, that is the rain, everything is a historical. So hydrogeology is nothing but you are going to the study for water, the quality of water or the unquality of water. This quality of water used for the agriculture purpose or the plant purpose, everything. But for example, water chemical composition H2 and pH is 7 is the suitable for the drinking water. The above 7 is not suitable for the drinking purpose. This we are going to the study for the hydrogeology. The Indian geology, a branch of geology that deals with the study of our motherland in connection with the coal petroleum. So, physiography, stratigraphic and economic minerals of India. This is everything we are going to the study for Indian geology. Resources engineering and photogeology. Resources engineering, this one study of water, land, solar energy, minerals, forest, etc. Fulfill the human wants. This is everything we are going to the study. Water, hydrogeology, land, the river, everything. Solar energy, minerals. For example, minerals mean pyrite minerals, limestone minerals, and lot of minerals is available. Forest, thick forest, everything we are going to the study for the resource engineering. Photogeology, the study of aerial photograph. So at present, this place, the climate changes is available. We are going to take the photo for the aerial satellite. Then you are seeing the photograph or explain the lot of matter. So this one is the photogeology. So structure of the earth and its composition. So there are structure. Inner structure, first of all, crust and mantle and solid. There are 3 layers of the earth. This one the mantle, inner liquid, inner core, and the solid inner core. There are 2 divisions of the core is there. This is the interior of the earth. How to the earth formed? You are going to see this diagram. There are 3 divisions of the earth: crust and mantle and the solid core. This of the crust and the mantle, there are 2 types, the inner core and the outer core. This one indicates the structure of the earth and its composition. This one 4th layer, the inner core. There are divided into the 4 main layers. First one inner core, second one outer core, third one mantle and crust. There are 4 layers the interior of the earth. The interior of the earth, there are astrosphere, the layer, first inner core, outer core, mantle and crust. The crust thickness, the 0 to 100 kilometer, the thickness is there. So this next one, astrosphere, lithosphere, there are 3 layers. How to form this the interior of the earth? This slide shows the crust. The earth crust is like the skin of the apple. For seeing this slide, the earth crust, the skin of apple. It is very thin compared to the other 3 layers. The crust layer very thin, up to 1% of the earth. The crust of the earth is broken into many pieces called the plate. So this one, the crust of the layer is broken. So many plate is formed. This one Indian Ocean, continental of the Africa. This is for example. The mantle below the crust. First layer the crust, next layer the mantle. The mantle is the largest layer of the earth. This one very largest. The mantle is divided into 2 regions, the upper and lower section. This one upper and lower section. So next the core. What is the core? Core of the earth like the ball of the very hot metals. Core is a very hot area, 1400 miles thick liquid, the iron and nickel. Only the iron ore and nickel ore is the very large occur in the layer. The outer core is the made up of the iron, is very dense. So outer core is fully covered for the iron. So this is the outer core. Next the inner core. Temperature and pressure so great. that the metal are just covered together and are not able to move. The inner core is a solid. So this diagram indicates the outer mantle and inner mantle is the other thing. So next one, weathering. Weathering process occur at the near of the earth's surface and produce the change to the landscape that influence surface and subsurface topographic and landform development. Weathering is a physical disintegration or chemical alteration of the rocks that are near the surface. Erosion is a physical removal and transpiration of the weathered material by the water, wind, ice or gravity. Sometimes the over rain is there, some places they eroded and over wind is coming, that time some places the sand is one place to another place is the transporter. So this one is called the weathering and erosion. Types of weathering. How many types is there? Mechanical weathering or the physical weathering. So what is the chemical weathering? Next one, chemical weathering. Is the physical disintegration. Physical weathering or mechanical weathering means physical integration and reduction of the size in the rocks without changing the chemical composition. That is called the mechanical weathering. Example, exfoliation, forest wetting, salt wetting, temperature changes and abrasion. So this is an example for the mechanical weathering. Chemical weathering, this one decomposes, dissolves, alters or weakness of the rock through the chemical process to form the residual material. The example, carbonization, hydration, hydrolysis, oxidation and solution. This for example of the chemical weathering. So biological, third one is the biological weathering. Is a disintegration or decay of the rocks and the mineral caused by the chemical or physical agents of organism. Example, organic activity from the lizard and algae rock, disintegration by the plant or root growth, burrowing and tunneling organism and oocyte secretion. This is called the example of the biological weathering. So next one is the soil. So the civil engineer were going to this very important the soil studies also. So what is the definition of the soil? Can be defined as the organic and inorganic materials on the surface of the earth that provide the medium for the plant growth. Soil develops slowly over time and it is composed of the many different material. Inorganic material are those materials that are not living, include weathered rock and minerals. The weathering is a mechanical or chemical process by which rock are broken down in the smaller pieces. As rocks are broken down, they mix with the organic material, which are those material that originate from living organism. For example, the plant and the animal types. This is the weathering. Formation of the soil. How to form the soil? So soil formed by the process of weathering of the rocks. So weathering of the rocks, that time the soil formed. That is disintegration and decomposition of the rocks and the mineral at or near the earth's surface through the action of the natural or mechanical and chemical agents into small grains. The factors affecting the formation of the soil may be atmospheric, such as changes the temperature and the pressure, erosion and transportation by wind, water and glaciers, chemical action such as the crystal growth, oxidation, hydration, carbonization and leaching by the water, especially the rainwater with the time. So, in general, the formation of the soil takes place by two methods. First one, the physical disintegration of the rock. Next one, the chemical decomposition of the rock. These two methods, the soil form. Physical disintegration, first temperature changes, wetting action of ice, spreading of the roots plants, abrasion. So this four, so physical disintegration of the rocks. Chemical decomposition of the rock, hydration, carbonization, oxidation, solution, hydrolysis. Based on constituents, soil may be classified as the inorganic soil, the organic soil. There are two types of the classified types of soil. The more common classification system are unlisted flow, geological classification, classification by the structure, classification based on the grain size, unfilled soil classification system, preliminary classification by the soil types. There are more common classification of the soil. Geological classification, the soil types may be classified on the basis of the geological origin. The origin of the soil may refer either to the constituents or to the agencies that are responsible for the present status. Based on the agencies responsible for the present state, the soils may be classified under the following types: residual soil, transported soil, alluvial or sedimentary soil, aeolian soil, glacial soil, lacustrine soil, marine soil. Over the geological cycle, the soils are formed by the disintegration and weathering of the rocks. These are again formed by the compacting and cementation by heat and pressure. So, effect of natural agencies. Geological work of river. During the life, while the following form head of the mouth, the rivers are capable to the extremely greatly modifying influence over the topographic of the region through which they flow. The geological work by river may be broadly divided into two well-defined phases: erosion, transport, and deposition. Geological work of river. Method of river erosion. By erosion is meant disintegration and decomposition of the rocks and soil material by the natural agent through the mechanical, chemical and other physicochemical process accompanied by removal of the disintegrated or decomposed product of the fall of places by the same agent. The stream and river are the most powerful subaerial agent of erosion. Others are wind and ice. Waterfalls. These are defined as the magnificent jumps made by the streams or river water at certain specific part of their course, where there is a sudden and considerable drop in the gradient of the channel. Many falls are easily attributed to the unequal erosion of the channel drop within a short distance due to the inherent nature of the rocks. Waterfalls. This slide shows the waterfalls. Stream terrains. These are benches like the ledges or flat surface that occur on the sides of many river valley. So this one is the river valley. From the distance the way appear as succession of the several steps of big natural strain case rising up the river foot. So stream terraces, these all are indicate the stream terraces. Next one, sediment transport by the river. For example, this is the sediment. The over rain is come this place, the lot of sand is there, this one transported one place to another place, is going to the deposited the next place. So this one sediment transport of the river. So alluvial fans and cones. So this one the shapes, they indicate the cone shapes or fan shapes. So these are the transported one place to another place, the river, the transported the sediments. This shape indicate the fan, this shape indicate the cones. So that is called the alluvial fans and the cones. The natural leaves. Okay, this one, this river is going to this naturally formed. So delta. So the biggest river is going some tributaries. Tributaries means the branches of river. So that is called the deltas. Channel deposit. What are the going to the channel deposit? One place to another place, or going to the channel. The biggest river is going on. Some places, some tributary channel is going to deposit. The river Mantari, we are going to the shaft, Mantari shape. This river going to the 6 shaft shape. That is called the Mantari. The Oxford Lakes. This lake shapes the Oxford Lakes. This diagram indicates the Oxford Lakes. The geological work of wind. Air in motion is called the wind. The wind is one of the 3 major agents of the changes on the surface of the earth. Other 2 beginning, river and glaciers. Wind acts as the agent of erosion, as a carrier for transporting particles and grains so eroded from one place to another place, and also for depositing the huge quantity of such wind flow material at different places. There are 3 modes of activities like erosion, transportation and deposition by wind. Geological work by winds. Wind erosion. Wind perform the work erosion by at least 3 different methods. First one, deflection, abrasion and attrition. Meaning of deflection. The wind possesses not much erosive power over the rocks. The ground covered with the vegetation, but when moving with the sufficient velocity over dry and loose sand, it can remove of the sweat away huge quantity of the loose material from the surface. This process of the removal of particle of dust and sand by the strong wind is called the deflection. What is mean of abrasion? Wind becomes a powerful agent for roughing and abrading the rock surface when they naturally loaded with the sand and dust particles. This type of the erosion involving the roughing, grinding, polishing of the rock surface by any natural agent is termed as abrasion. Next one is attrition. The sand particles and other particles lifted by the wind from different places are carried away to considerable distance. The wear and tear of load particles suffered by them due to multiple impact during the transportation process is termed as the attrition. So, this diagram indicates the wind erosion. So, this one is the deflation. This one is the depletion, the concentration of the larger bubbles, then the desert submergement. So, this diagram is the depression. Wind operation. So, sometimes the overwind is this part of rock material is going to deposit the another place. This is the abrasion. The losses. So, the overwind is this is first forming of the rock. The shape is smoothly. Then after again the wind, this place again the wind is come. This places the loosest material is transported to another place. So geological work of groundwater. This one aquifer and wells. The artesian well, flowing artesian well. This is the zoomatic surface. Mesomatic surface. This is water table well, unconfined aquifer. There are 3 types of the aquifer. One is the confining aquifer, unconfining aquifer. There are 2 types. This one is the water table, third one. So this diagram indicates the work of groundwater. Geological work of groundwater. Groundwater, like the surface water, is also very powerful natural agent responsible not only for the modifying the existing features but also for sustaining many other geological features on and below the surface of the earth. The geological work of the groundwater may be conveniently studied under the 2 headings, namely chemical work and mechanical work. So, geological work of groundwater. The water is the great servant. The groundwater becomes an active agent of dissolution of many rocks like stone, dolomite, gypsum, rock salt, and like it comes into the contact during the downward journey below the surface. It has been observed that water dissolves limestone at a variable rate that depends upon the temperature, composition, and above all its carbon dioxide content. The dissolution of the soluble rocks by groundwater is controlled by the number of factors such as climate, geological structure, topography, porosity, and permeability of rocks. Composition of the rock, composition of the groundwater, especially its salt and gaseous content, the flow velocity, temperature, pressure, and depth at which the water comes into the touch with the rock. This is on the geology work of groundwater. Diagram indicate this is dolins. This diagram indicates the dolins, caves. Some caves forming the earth's surface, blind valley. This one is indicate the blind valley surface. This one stalactite. This is the indicate the stalactites. This one indicates the stalagmites. Geological work of ocean. So next one is ocean. So geological work of ocean. The marine water is spread over more than 2/3 of Earth's surface and is classed among the most powerful geological agent operating in the Earth. Marine geology is fast acquiring the status of the separate branches of geology, where the study of oceans, as said above, has become the domain of the specific branches of the science, like the geological agencies. Seawater also acts as the agent of erosion, transport, and deposition. Since seawater is almost confined within the boundaries and broadly standing in the natures, unlike the river that flow downwards. The mechanism of the geological work of the sea differ in the detail from the river. All the geological work performed by the marine water is due to the regular and irregular disturbance taking place in the body of water, mostly in the surface of the layer and distinguished as the waves and the currents. So, this is a geological work of ocean. This diagram. This also. Then the marine erosion. Marine water erodes the rock at the shore and elsewhere which it comes in contact with the manner broadly similar to the stream water. The work of erosion is accomplished in 3 ways. First one, hydraulic action, abrasion, and corrosion. First one, hydraulic action, is the process of the erosion by water involving breaking, loosening, and plucking out of the loose, dissolving the blocks of the rocks from the original place by the strong forces created by the impact of sea waves and the currents. Marine abrasion involves the roughing and grinding action of the seawater of the rocks of the shore with the help of the sand particles and other small fragments that are hurled off again this rock. Corrosion. It is the solvent action of the seawater which is particularly strong in the environment where the sheer use of the renewable and composition. Next, marine erosion. This slide. This is a marine abrasion. This is a marine corrosion. So, geology work of oceans. This slides. Also, sea cliffs. Say, waveguard terraces. This indicate the waveguard terraces. This one wave cut terraces. This waves come, then go, come and go. So this shape is forming. Wave cut terraces. Beaches, forming the beach. Splits and bars. Tombola. Coral reef. Geological work of glaciers. Glaciers are defined as a huge bodies of the ice characterized with the downward and outward movement. They are formed in suitable climate and topography in favorably located region. Under its own load after falling over an area for considerable time, the snow undergoes a process of progressive compaction. With the continued compaction due to increasing mass of snow from above, after every snowfall, form undergoes further change to a very compact, dense, coarsely crystalline masses. The condensed, compacted and solid masses of the snow is defined as the ice or glaciers. This one is the glaciers of the snaps. The inside of the marine, inside of the ocean, the lot of glaciers. The next one is the earthquake. Earthquake are caused by the passage of vibration set up the rocks due to the various regions. All the important sources, once which are felt over the extensive area and causes widespread damage, are due to the sudden movements along the fault associated with the organic and abinorganic earth movements are called the tectonics. So these are earthquake forming. How to earthquake form? This is on the center of the point. This focus, fault plate. Seismic waves form the inside of the earth's surface. So the earthquake occur along the plate margin. Next, this is the earthquake of the slide. How to form the earthquake? The focus point. This is the epicenter point. This is fault. Fault place means the one plate to one plate. The movement. The plate. Massive rocks are the make up the other layers of the earth's surface and whose the movement along the fault triggers of the earthquake. The seismic waves form. So next one, earthquake. Waves are formed. This one P waves, S waves. The earthquake slide. This one India. Earthquake zoning. What are the places? There are the 4 zones. Zone 1, zone 2, zone 3, zone 4. There are dividing about the 59% of the land area, the India is liable to the seismic hazard damage. So these are the earthquake zoning of India. Diagram, the map of India, the how many places the earthquake is forming. This map shows the seismic zone of India. Next one, earthquake zoning of India. So the totally the India which place the earthquake forming. This diagram as map is indicating. Thank you.